Alright, let's do a quick introduction to vectors. We're used to thinking about numbers, a number like 4, right? A number like 4 represents 4 things, but 4 can also represent the amount of steps you can move in a direction. So when we're talking about the number line in 1 dimensions, 4 can either represent 0, 1, 2, 3, 4. 4 can either represent this place on the number line, 4, or it can represent an abstract quantity like 4 units. So, for instance, we could think of 4 as being the distance from 2 to 6. This is also 4. So, we're going to take the more abstract idea of this 4 being a distance or a direction, and we're going to expand that to talk about in higher dimensions. So, for instance, let's say we're in 2 dimensions. We can talk about our point, right? So we've got a coordinates that are 2, 3. All right, but we can also talk about a direction. So a magnitude and direction. We can talk about a vector would be something that looks like this. We often draw it with an arrow. And this vector, this blue quantity, we're going to put in angle brackets instead of the round parentheses, right? These are parentheses. And these are angle brackets. And what we mean by this is that this arrow is it's got a direction and it's got a magnitude, but we shouldn't think of them as having a fixed position, because, for example, we could start the vector down here. If we start it down here, this is the same vector. This is the vector 2, 3, because it goes from a point, and it goes 2 units in the x direction and 3 units in the y direction. So there's a difference between these coordinates 2, 3. These represent the coordinates, and these blue values represent a vector. So it doesn't have a fixed position, but it has both. It has as many coordinates as the space where you're in. So similarly, we can do this in 3 dimensions, right? So we can do this in any number of dimensions. If we're talking about a vector, let's say a vector, remember this is x, this is y, this is z, we can talk about maybe moving 1 unit in the negative x direction. So we're going to start at the origin. We're going to move 1 unit in the negative x direction. We're going to move 2 units in the positive y direction, and we're going to move 1 unit in the positive z direction. So that gets us to the point -1, 2, 1. So these are the coordinates of this point. But what we can draw is we can draw the vector that goes from the origin. So the vector from the origin, 0, 0, 0, to the point -1, 2, 1, is the vector that's with angle brackets -1, 2, 1, because it's a direction and a magnitude that goes -1 unit in the x direction, 2 units in the y direction, 1 unit in the z direction. And if we were to move this point, if we were to move this vector to start here, so it was going to start at 2, 0, -2, right? This is 2, 0, -2. And if we were to draw this same vector that goes -1 unit in the x direction, 2 units in the y direction, and 1 unit in the z direction, where do we end up? We end up at 1, 2, -1, because 1 unit, -1 unit in the x direction changes 2 down to -1, 2 down to +1. 2 in the y direction changes 0 to +2, and -2, if you go 1 unit in the z direction, you get to -1. So this is the same vector, -1, 2, 1, but when you put the tail of the vector here at 2, 0, -2, then the head is at 1, 2, -1. So I hope this has cleared up the difference between the coordinates and a vector. This vector you can move around. It doesn't have a tail. It doesn't have a place where it leaves, where it's fixed. It's a generic statement that has a direction and a magnitude. And so when we're writing them, and in the book or in different places, you'll either see like a bold letter, a V for vector, or a V with a bar over it, or a bold V with an arrow symbol on top of it. All right, so these vectors, think of them as arrows. I am a vector. What can we do with the vectors? Well, we can add vectors. So if we want to take our vector u and a vector v, hello u, hello v, what we do is we take the tail of v and we put it at the head of u. So we bring this over. Actually, we can do that really nicely here on the tablet. Maybe. Dun, dun, dun. Let's see if this works. No, it doesn't. It wants to do the whole thing. That's all right. We're going to take the whole vector v, and we're going to bring it down here. This is the vector v, right? It's the exact same thing. It has the same direction, same length. And it goes here. And now we define u plus v to be the vector that starts here and ends here. So let's choose the color there. So this part right here, this is the vector u plus v. So that's how you add two vectors. If you think about what's happening, so component-wise, so if you're doing this and you need to do it with some numbers, you can, so let's write it in words, to get the the components of u plus v, you can add the components independently. So u1, comma u2, comma u3 plus v1, comma v2, comma v3 gives us u1 plus v1, u2 plus v2, u3 plus v3. Let's talk about some of the properties. What happens when you add vectors? So if we take u and we add the 0 vector, right? The 0 vector is what happens when you have 0 in all components. Well, if you add 0 to each of the components, you're back to where you started. In other thoughts, this 0 vector is the vector that doesn't go anywhere. All right. We also have that u, if we take the vector u, and we take the vector v, that's equal to what happens if we take the vector v and we add the vector u. And the reason for that is because it's a parallelogram. These two are perfectly parallel, these two are perfectly parallel and equal, and so you end up at the same spot. For both cases, this is u plus v, and it's also equal to v plus u. All right, you can also stretch a vector. So stretching a vector looks like this. If this is our vector v, then we can multiply it by, here's 2v's, right? V plus v is 2v. This is 2v because it's twice as long as the vector v. And you can also do negative v if you go backwards. Of course, if you take 0 and you make it have 0 length, multiply the length by 0, you have the vector that doesn't go anywhere. You have the 0 vector. Similarly, if you take the 0 vector and you multiply by anything, you get back the 0 vector. So if you want, that means you can subtract vectors, right? u minus v is equal to u plus negative 1v. So u v, then if v is like this, then that means that negative v looks like that. I should probably not put an arrow for my, since we're dealing with vectors. So if this is v, then this is negative v. And so then u minus v, so u minus v, then this is u plus negative v, which is equal to u minus v. And then we can do some distributing. So if we do a plus b times v, that's a times v plus b times v, or if you do c times u plus v, you get c times u plus c times v. All right, and so kind of already said this, but I'll just quickly say it again. How do you compare a vector to the set of coordinates? Well, if we start out at the origin and we walk 1 unit in the x direction, 4 units in the y direction, 3 units in the z direction, then we've started at 0, 0, 0, and we've gone in the direction of this vector 1, 4, 3, so we end up at the coordinates 1, 4, 3. So there are, whatever the dimension of your space is, there's that many special vectors that are called the standard basis vectors. right? If we have x, y, and z, then the vector that goes 1 unit in the x direction, that's called I. 1 unit in the y direction, that's called j. And 1 unit in the z direction, that's called k. And those are the standard basis vectors. And one reason why those are super useful is because we can rewrite your vector as a sum of those. So this is 1 unit, this is 1 times 1, 0, 0, plus 4 times 0, 1, 0, plus 3 times 0, 0, 1, which means we can rewrite this vector u as I plus 4j plus 3k, which is what we have here. Right? And so when you want to add vectors, you add them component-wise. That's what we've talked about. If you want to scale something, you can multiply scalars component-wise as well. Pi times u is pi times 143, which is pi, comma 4 pi, comma 3 pi. And the last thing that you need to know about vectors right now is talking about the magnitude of a vector. And the magnitude synonym for the length of a vector, and you can either write it as length v, so you write this as length v or magnitude of v, which is 1 bar around it or 2 bars around it. So what's the magnitude of the vector? Oh, haha. The magnitude of the vector u is what happens when you take the distance from 0, 0 up till 1, 4, 3, the length. So you can always calculate it by taking the square root of first component squared plus second component squared plus third component squared. In this case, that's 1 plus 16 plus 9, that's 26. Square root of 26, that's the length of u. Similarly, we can find the length of v, square root of 0 squared plus negative 1 squared plus negative 3 squared. That gives square root of 10. And so a key thing you can do with a vector is to create a vector that has the same direction as the vector, but has length only 1. So if we have this vector here, but we'd like to find the unit vector that has length 1, well, you can find the length of the whole vector and divide by it. And that gives you what the unit vector is for it. So how do we find the unit vector of 2, negative 1, negative 2? Well, we have to find the length, and that's the square root of 2 squared plus negative 1 squared plus negative 2 squared, which is the square root of 4 plus 1 plus 2, which is 9, and the square root of 9 is 3. So the unit vector takes this vector and divides by its length. So we get the vector 2/3, negative 1/3, negative 2/3. And that's the unit vector in that direction. Alright, that's it for a quick introduction to vectors and what you can do with them. Alright, see you later.